Something I just thought about it to ask you. Now you've seen two methods. A method that we find the volume from profiles by finding the side area, then multiply by the width of the excavation. And I'm hoping that everyone understand that this method you can apply it only if you have a vertical size of excavation. Once you have a sides like a size 1 to 1, 3 to 2, any side slope, then you cannot use this method here by finding the side area and finding the volume from the side area. Rather than you need to find cross section area. So this one here is finding the volume from cross sections. Find the volume from cross section, where you have to find the cross section area, and then from the cross section areas use them in trapezoidal or Simpson to find the volume. This method here, I want to mention, I want to make sure that you guys understand that this method based on cross-section area is the general one. It can work no matter what, whether you have a vertical side of a slope or you have a side slope, okay? And I just want to just remind you, if we want to go this way on the first problem here, look at this, please. So here is our first problem where we found the side area from this depth of cut. You know what you can do? You can simply add here another row in your table, and this row here will be cross-section area. Cross-section area. And let me ask you, how can we find the cross-section area? If my depth of cut is 1.9, if this number is 1.9 meter, how can we find the cross-section area? And remember, the cross-section area is simply, this is your cross-section area, which is simply a rectangle. So how can we do that? You simply have to multiply 1.9 times 1.75, and so what you do is you write it here. So this number will be 1.9. This number here will be 1.9 multiplied by 1.75 if you agree, huh? 1.75. And remember, for every section, there is nothing new. You have to multiply 2.4 times 1.75, 2.8 times 1.75, and so on. And see, the 1.75 is the point, huh? So really what I want you to take from this discussion is that calculating the volume based on the cross-section area is the general one. It can work if you have a side slope or you have a vertical size of excavation. However, the method that's based on the side area, it is only limited to only whenever you have a vertical size of excavation. And this is written somewhere on my slides here. When you read the slides, you will find this is very clear. So we're done with this presentation here, and we're going to our next presentation, okay? And so my next problem here is another road segment. But this road segment is a little bit different from the one we had before, and I will show you how. Let's first of all, let me show you what information do we have. Look at this, please. So we have the length of the road is 150 meter. The road width is 5 meter. The road elevation at the start is 97.5 meters. The road slopes up at 6.67%, and the side slope is 1-to-1 in cut, and also 1-to-1 in fill. Okay. Now, this problem here, why it's different or how it's different from the one I did before is that we will have cut and fill in the same problem. The previous problem, we had only fill, and this one, we have cut and fill in the same problem. And I'm going to show you the cross-section, how it looks like in cut and fill. So the one on the top here, this is the cross-section in fill. Okay, you can see my ground is here, where we started always, and then we want to build our road, which means I need to add some layers of of fill to build my road. How about here? Remember, I always start from existing ground and I go to my road elevation. And obviously, you have to remove this amount of soil to build your road. So this is a section in cut, and this on the top here is section in fill. Now, let's go ahead and do the profile. So I'm not gonna spend more time on the profile because probably you guys are aware on how to draw the profile. Huh? So look at this, please. So here is my profile. My magenta line is my existing ground. My blue line is my design elevation. Remember, my road starts here at 97.5 and it goes up by a slope of 0.67%. Look at the table. So the table here, same, no change. We have a row for station, another row for existing elevation, and then we have a row for the road elevation. I need to ask you for the last time. If I gave you the road elevation here, 97.5, and I gave you the slope of the road is 0.67 here, 0.67. Are you able to figure out all these numbers on the road? Let me hide it. Please confirm. Are you, with the help of the elevation at the start and the slope, are you able to figure out the elevation on the road? Like here, what's my elevation here? What's my elevation there? What is my elevation there? And what's my elevation over there? And finally, what's my elevation here at the end of the road? Anyone until now is not able to find the elevation on the road based on given point and a slope? It means if everybody's quiet, it means you guys can do it, huh? It means you can do it. Next is, I'm gonna remove this box here. I'm assuming that you guys can do it, okay? Now once you have the road elevation, then you can find the depth of cut and depth of fill. It's very simple, watch this. So on this picture here, okay, I'll zoom in. What do we call this depth here? Cut or fill?
Fill.
Fill, because the road is above, the blue is above the magenta, and this is fill. So this is fill here. Okay, one more time if you're not following, one more time. If I go here, remember the magenta is existing ground and the blue is your final road elevation. So what do we call this one? It's over there, it's already for you. This one is depth of cut. Do we use sine or cosine to do that, or just subtract two elevations? Please let me know. So we don't use sine or cosine, it's very simple. So we want to go ahead and subtract the road elevation. Look at this. So the existing ground is 97 and the road elevation is 97.5. This means my road is above and we have a depth of fill of 0.5. So you subtract 97.5 minus 97. So you go 0.5. The only difference between this problem and the previous problem is that we don't mix and match. And what does it mean? Look at the difference between my table now and the previous problems. Anybody can see the difference between this table and the previous table?
We separate the fill and then cut.
Exactly. Thank you so much. So you can see here, the difference is very clear. We instead of having one row and we call it either cut or fill, now in the same table, we have two different rows, one for cut, one for fill, and we don't mix, okay? So what happens here, look at my profile, look at my numbers, and you can see here, this one is fill, and you can see the 0.7, which is from here to there, which we can subtract the road minus the existing ground, so 0.7, and it went here into my depth of fill row. Again, look at this, look at the profile, you can see it's 0.4. I want to mention that how can we put the number in cut or fill? There are two methods. Whether by numbers, look at the numbers, you can see here I say road is higher than existing. So this goes into fill. Road 97.7 is more than existing. So this goes into fill. 97.9, 97.5. So also we have a 0.4 difference. And the road is higher. So it goes into the fill. Let's go to the other side. Here we have existing ground 98.7 and a finished road or road is 98.1. So the existing ground is higher than the road, which means we have a 0.6 and it goes into the cut. The other option is if you already done the profile is a fantastic way to tell you where is the cut, where is the fill, huh? What do you think? The profile is even easier because all you have to do is look at the blue line and look at the magenta line. If the blue is above, then this is fill. If the magenta is above, this is cut. Okay, next is we simply have to do the cross-section area. Okay, look at this. So we have to add to our table two more rows. One is called area of fill, and this one here is called area of cut. And those are not side areas. Those are not side areas. Those are cross-section areas. Now, I'm going to give you some example on how to do that. For example, let's find out what is my area at 0. Okay, so the area at 0, which we know it's a fill, huh? So this number is equal. Remember the equation, huh? W multiplied by C plus Z multiplied by C to the power 2 squared, huh? So W, if you guys go up in this document here, you will see my W is, I'm going to go up for you guys. Look at this. So how much is my W? Anybody can see it?
5.
Okay, and also take a look at the side slope because we need it, huh? How much is my Z? Any help?
1.
1.
1. Okay, so look at this, please. So here is my area again. So the 5 is my W is 5. And then multiply it by C. Where can I get my C? And remember, C is the depth of cut or the depth of fill. So we're talking about area at section 0. How much is my depth of fill? Look at the table. Look at my screen.
0.
Not 0. Not 0. Look at my screen. How much is my depth of fill at station 0?
0.50.
0.5. Exactly. So this number is 0.5. Plus, we already agreed that our Z is equal to 1. And then multiply by the C, which is 0.2. Okay. So guys, you take the 2.75 and you put it here in the area of fill. Let me give you another example over there at the end. So I'm going to do here area at 150, I guess. 150, that's correct. So this is equal, we have the same road width, so it's 5 multiplied by the depth. How much the depth of cut at station 150?
0.6.
Nope. The depth of cut at station 150, which is the end of the road.
1.4.
1.4, correct. So 1.4 plus your Z is still 1 to 1 in the cut, multiplied by 1.4 to the power 2. And when you do the math, it will give you 8.96. You just have to copy this number, place it here in your table. Okay? Now, I know that we're very close to do the final calculation for the cut and fill volume. So you can see so far what we've done is we estimated the depth of cut, depth of fill, and then cross-section area of cut and cross-section area of fill. To proceed, there is a very important point, which is where is the transition? Okay, watch this, please. So if my problem is entirely cut or entirely fill, like what we've done in the last class, then that's easy, huh? If you look at the problem that we solved today, that's easy. If all those numbers are area of cut or all of them are area of fill, that's easy. We go through them, all them into trapezoidal or into Simpson to find the volume. Now there is a problem. we have some areas which we will need to cut and some other areas we will need to fill. Now, what they do is, you say, okay, Tahir, listen. Now, how many totals in number? We have 2.75, 3.99, 2.16, all the way to 8.96. Why don't we just throw them into trapezoidal and we can get a volume? You guys agree or disagree on what I said? What if we take all these numbers, cut and fill, it doesn't matter, we place them in trapezoidal and we find the volume? Do you agree or disagree?
Disagree.
Disagree.
Disagree, correct, please. You need to disagree because simply we don't mix and match. We estimate the volume of cut by itself and the volume of fill by itself. And look at how easy to do that. Watch this. Guys, what if I hide this part? You can see here, there is a point where the blue meets magenta. Can anybody tell me this point, what does it mean? Where the blue meets magenta?
There's no cut or fill.
Thank you so much. There's no cut and fill. So, one side of this point is cut and the other side will be fill. I'm going to ask you, what if guys, if I hide this part? Okay, I'm going to draw a box here, draw a box, and then I will simply hide it. Now, based on what you learned so far, where I have here cross-section area, cross-section area, cross-section area, and then 0, are you able to figure for me the volume of fill? You don't have to go into detail, just tell me roughly what you feel. Would you feel okay to, I mean, you should be able to find the volume of fill if I hide this part?
Yes.
I guess so, because again, everything is fill. There's something, we've done it before, so I think we can do that. I think we can do that. How about if I move this box here? I move this box here, and I hide this problem here. Okay? What do you think? If I give you this problem, are we able to find the volume of cut? Yes, you can. Yes, you can. Okay. Now let me show you. So obviously we don't mix between cut and fill. We have to find the cut by itself, cut volume by itself, and the cut and the fill volume by itself, and report them separately. Now, before we do that, we need to find where is the cut. Where is the transition point? So this point here is an important point, and we have to figure out where. And remember, I know that my slide, it has a final answer, but I want you to imagine that this whole thing is unknown, okay? So this whole box here, I'm gonna hide it because simply when you start the problem, this is simply, it's not there. We only measure the elevation 0, 30, 60, 90, 120, 150, but we don't know where exactly those lines meet, which is not really a difficult problem. So in the next part here, I will show you how and our calculation. I'm gonna show you, go one by one. So I'm gonna show you how to find out where they meet, which is not very difficult. Let me ask you, anybody tell me, do we know this dimension from the road to the existing ground at station 60? Do we know this dimension from the table?
Yes.
Look at the table. Okay, let's zoom out. Do we know this dimension from the table? Any help?
0.4.
Thank you. Okay, how about the other dimension on the other side? So we go to the 90, which is here, from this point to this point here. Do we know this dimension?
Yes.
Look at the
0.
table.
6.
0.6. Thank you so much. Okay, now remember that when we don't know where, we can simply turn this into equations. So I'm going to move this a little bit. We don't know where, and we don't know where. I'm going to call from this point to this point. I'll call this one X because we don't know. So we're going to say that this X. And if we know X, then problem solved. We know where those lines met. Okay, so anybody to help me to find the value of X? And remember, we know that the distance from here to there, anybody to help me with this distance?
30 minus x.
30 minus x. I'm pretty sure that you've done this several times in CVT. So this is called similarity of triangles, where you can say, you can write here equation, very simple. You can say x divided by 0.4 equal 30 minus x. I'm going to probably do a bracket, so 30 minus x divided by 0.6. Anybody disagree on this equation? Okay, so you agree. So similarity of triangles. The x over 0.4 is equal to 30 minus x over 0.6. When you solve this very simple math problem, you'll get x equal to 12 meter. And if x is 12 meter, okay, so remember the x is measured from 60, huh? Between 60, it means where they meet at station 72. Okay, so we add 12 plus 60, so this is 72. And what happens here, if you wish, you can find also by interpolation, you can find the existing ground and the road elevation if you wish, but that's not required. But the thing is, at this section, do we have depth of cut or depth of fill? 0. And do we have area of cut or area of fill? No, we have 0. Are you guys following?
Yes.
Finally, let's find the volume. We're very close to end, so let's find the volume. So the volume here, and you know, I'm trying to just to reinforce some ideas here. So I ask you to do this problem, and I force you to do it using Simpson method. Simpson method. Now remember, the volume of fill is between 0 to 72. Let's put some dimension line. So the volume of fill, it goes from 0 to where the line meets. So this one is volume of fill, which is from 0. And the same thing, we can do the same thing here. So from this point to this point here will be volume of cut, and this will be from 72 all the way to 150 meter. Now let me check with you guys. Do you think I can find the volume of fill in one shot from 0 to 72 using Simpson method?
No.
No, you can't. And the reason why you can't, you have to look at the conditions. And we have two conditions. Number one, do I have the same interval, or it went from 0 to 30 and 30 to 60 and then 60 to 72? Looks like I have no constant interval. However, I can tell you we can go from 0 to 30, and then we can go from from 0 to 60, and then from 60 to 72. You agree?
Yes.
Okay, let's take the other condition. Let's count, please. How many areas? 1, 2, and then 3. So we have 3 areas. Is that odd or even?
Odd.
Odd. It means, here we go. It means, yes, I can estimate the volume from 0 to 60 using Simpson. Then I find this little volume between 60 to 72, and then we can add the volume cut of fill. Let's see here. So here we go. Watch this. So you want to go here and say 30 over 2. Watch this. So our constant distance 30. It's not 25. Why? Look at the stations. It's 30 divided by 3 because I'm applying Simpson. And then we have a big bracket that has one term and two terms. One here is the area number 1, and this is the area, the last area. Look at this, please. I'm going to zoom out. So 2.75 is your area number 1. And the last area at 60 is 2.60. Okay. And then we said in the Simpson, we said plus 2 multiplied by the sum of all the odd areas, not including first plus last. Do we have any? For Simpson, we say plus 2 multiplied by the sum of all the odd areas, not including first and the last. Do we have any?
No.
No, and that's why you can see here, think about this one as 2 multiplied by 0, which I didn't write here, okay, for the space. Plus 4 multiplied by the sum of all the even areas. Luckily, we have only one, which is the second one here. So 4 multiplied by 3.99. The only thing that probably it will bother you a little bit, okay, please take a note in here, how do we get the 8? How did we get the 8.64, which is simply the same, 60 and 72. This volume here is a volume that has one area at one end and 0 at the other end. Okay, I want you guys to visualize it. So this little volume here, probably I'll clean a little bit so you guys can see better. We're trying to figure out the little volume between 60 and 72, which is here. I'll zoom in. So we're trying to find volume here. So we have one area on one end, and this area goes to 0 where we have no cut, no fill. In geometry, this is called a pyramid. A pyramid. And the volume of the pyramid is 1/3 the area of the base times the height. The volume of the pyramid is the 1/3 the area of the base times the height. Okay? Which means what you have to do is you take the 1/3 the area of the base. Probably I'll write it here. So this number here, I'll give you the explanation of what is 8.64. So this one is equal to 1/3. The area of the base is 2.16 multiplied by the height, which is 12 meters. Okay. How we get the 8.64? This is the volume of the pyramid. 1/3 the area of the base, which is here. So this is the area of the base, 15 multiplied by the height, which is 12 meters. So this is how we find. So you add them together, you'll get 217, and this is your volume of. Now, I'm asking you, do you think there is any difference when we find the volume from 7? I would say we will follow exactly the same idea. Huh? We will follow the same idea where you cannot find the volume from 72 to 150 in one shot. And the reason why, because of the interval. Because from 90 to 150, the interval is constant. While from 72 to 90, it is not the same amount, not 30, which means you cannot. So I'm gonna repeat myself quickly. Yeah. So if to find the volume of cut, which is from 72 to 150, we have to split from to 90. So that's one thing. And then from 90 to 150. Okay. From 90 to 150, that should be straightforward because we can apply Simpson. Why we can apply Simpson? Because the station or the spacing is constant. That's 30 meters. And also the number is odd. 1, 2, 3. It means yes, I can. Let's see how can we do that. Okay, so it's going to be 30 over 3. So the spacing over 3, and then multiply by first plus last. So here is your first area, and here is your last area. And then 2 multiplied by the sum of all the odd areas, not including first and the last. Do we have any?
No.
So that's why 2 times 0. And then plus 4 multiplied by the sum of the even, which is we have only one, which is the second one, which is 7.44. And then finally, we have little blob like volume here, which is 20.16. How did I get this number? I'll show you. So this number here, the volume here is equal to 1/3 the area of the base, which is 3.36. The area of the pyramid, the base of the pyramid is 3.36, which is simply the area, cross-section area at 90. Okay, multiplied by the height, which is 18. Why 18? Anybody tell me why 18?
13 minus 12.
It's a 30 meter, which is the spacing, minus the x, which is 12. So we're left with 18. So this is how we get your 12.16. You can see here, guys, when you look at this problem, just a longer, it's not really any difficult, but it's just a longer. If you have a problem that has cut and fill in the same, all you have to do is you have to separate all the fill by itself and all the cuts. And also you have to figure out where is the transition, where is 0 cut, 0 fill. Okay. Any questions so far? Any question?
How you know the existing elevation at like where the level is 0?
Where there is no cut, there is no fill, you mean?
Yeah.
That's by interpolation. Again, you don't need it because obviously you can see I never used the 90, so I already got it here as extra for you, like the 97.98, this number here, and you can see the two elevations are the same, which is 97.98, and that's why we have 0 cut, 0 fill. But I can tell you, it's very simple. You just have to interpolate along the line. So I guess it's easier to do it from the road. From the road, we know the station is 72, and you can simply get the elevation from the road start. I can show you here. We can say the elevation at the start is 97.5 plus 0.67% multiplied by 72. Can you check me, please? When you do this, because you're trying to estimate the road at the road elevation at station 72. So we go 97.5. That's the road elevation at the start plus the slope, which is 7%, multiplied by the distance, which is 72.
Yeah, I got same. Thank you.
Okay, perfect. Now, guys, I have a discussion for you, and I'm sure this discussion will not finish today. So I'm just going to start the discussion. The discussion is this. When Tahir used, probably I have to go to the other presentation. Just give me a second here. If I go to part number 1, and I go to this cross section here, okay, I want everyone to look at my slide and look at my cross section here. Remember, I came up with this equation, which is the cross section multiplied by C plus ZC squared, because simply I said that this shape here is trapezoidal shape, and this trapezoidal shape has an assumption, and the assumption was that, remember, I was given the existing ground here at the center line. I was given the existing ground at the center line. And what I did, I assumed that my ground is going to be constant across. So there is not a change of elevation on the cross section. Would you agree?
Yes.
No, now I'm asking you, is that valid assumption or not valid assumption? It depends. If the reality matches my assumption, it means I'm still okay, my volume will be great. But I'm asking you, what if in reality my ground on the cross section goes this way, and let's say my ground goes this way, okay? So my ground is not really constant. So my center line elevation, it's not really the same across my cross section. Now I'm asking you, do you think this equation will still be valid?
No.
No. Okay, so really I'm gonna say it one more time because it's very important. So far in every problem I had for you so far, we only had one existing ground for every section. I'll show you. For example, if I zoom out and I go here, I'm asking you every like in the input, look at this plan view. I'm asking you in every cross section. Remember, the cross section is perpendicular to my center line. So it's a cross section, and that's another cross section. I'm asking you in every cross section, how many existing ground do we have, or did we measure? How many existing ground did we measure for every section?
Just
2,
one.
3, or 1?
2.
Can you tell me, sir, where are those 2 existing ground points? Like on my slide right now?
Yeah, at the beginning, with the read 0 plus 0, 0, and then 25.
Yeah, but those are 2 different sections. I remember this is a plan view, and the red line is a cross section. It's only one, sir. It's only 1 point. In every section, we have measured only one existing ground point. And in my calculation, look at this. What I did is I assumed that where did I measure my existing ground? It's here. Look at my arrow. This is where I measure my existing ground. And I assume that's constant. It doesn't change. The thing is, if this is the reality, great. It means my equation is correct. It means all my calculation is correct. Now I'm asking you, what if this is not true? What if my surveyor only begged for me only 1 point under the center line of my road, but in the cross section visually you can see the ground is simply follows this red line. Now I'm going to change the line type like this line here. This is my existing ground on site. If I simply ignore the change, and I went the same method that I teach you so far, what happens to my calculation? Is it going to be truthful or just numbers and it doesn't match the reality?
It'll be wrong.
It will be wrong. And that's why this will take us into a deeper discussion here on this presentation here, which is something called 3-point cross section. So look at this section here. So this is a generalization, a little bit generalization over 1-point cross section. So in all the work we've had so far is that we, for every section on the road, we only survey 1 point. And sometimes this is okay. If you look visually on site and you look that the existing ground is kind of flat across your center line, then it should be okay. So 1 point is sufficient. How about if my existing ground is more complicated? Let's say I look at the cross section on site and I can see some changes. Look at this. Looks like in order for my numbers to be truthful and my calculation to be correct, then I have to survey more than 1 point per cross section. Look at this. So you can see here, I have 1 point. So I need to find the elevation of this point. I also need to find the elevation of this point. And I also need to find the elevation of this point here. Okay. And this will lead us to 3-point cross section. 3-point cross section. Before I let you guys go, I need you guys to imagine that there is no change of the method. The method will be the same. So I need to find the depth of cut. I need to find the cross-section area. I need to find, after I find all the cross-section areas, then I can use Simpson or trapezoidal. The only difference is I cannot use this equation anymore. That's the only difference. That this equation here, which the area equal WC, you cannot use it anymore, because simply the geometry, it's not really a trapezoidal. However, we have a different shape, which we will figure out next time. So the next time, we'll help you guys to find what is the area of the cross section if you have a 3-point cross section. If you have a 3-point cross section. But I want to emphasize that this is the only change. This is the only change. If I'm able to find an alternative formula or equation that gives me the cross-section area of this weird figure, then everything else stays the same. Are you following?
Yes.
Okay, and this concludes our class today. I'm hoping that the quality of the network doesn't affect us much. It's something out of my control. And again, feel free to look at the presentation, read the material. It's very important. And if you come across any question, then you know what to do, huh? If you come across any question, if you're still unsure, please contact me.
Tahir?
Thank you so much. Okay, go ahead.
So for an exam, you would just give us those initial 5 points or whatever, and it would be up to us if we want to draw a diagram, how we want to make our table, that kind of thing, or do you give us templates that we fill in?
You're referring to the 3-point cross section?
Yeah, just for like an exam, you would just give us like the 5 initial points, like the road length, the road width, the starting elevation, the slope percentage, and then we would just...
Yes, you will be given exactly what you've seen here in this example, and your job will be your job will be to create the profile and then build the table on here. Okay, and remember there is an assignment which I will release sometime tomorrow not for you guys to submit it as soon as possible, but since you're asking and inquiring about how the question will look like, the assignment will give you a good idea of how the midterm exam will look like.
Thank you.
No problem. Okay, guys, with this one, I just want to wish you to stay warm, and have a wonderful weekend. Thank you so much.
Thank
Thanks.
you.
Have a good day.
Thank you.
You too.